Welcome in .Cool. After our previous JWST black hole series, here's the latest. Astronomers have used JWST's infrared eyes to spot dormant black holes flare into life by shredding passing stars, events hidden from older telescopes. This first direct detection of dust-obscured tidal disruption events reveals a hidden population of black holes. Keep watching this video to see how JWST uncovers the universe's darkest secrets. The discovery tidal disruption events, or TDEs, occur when a star drifts too close to a supermassive black hole and is torn apart by gravity. The shredded material forms a rapidly heating accretion disk, producing a sudden flare of radiation. Such events are rare, and until recently astronomers have recorded only about 100 of them. The main obstacle has been dust, which blocks most of the light from reaching Earth-based or space-based optical and X-ray telescopes. Infrared light, however, can travel through dust. This is what made NASA's NEOIST mission a useful first step. For over a decade, NEOIST scanned the sky, and researchers later applied algorithms to its data to search for unusual short-lived bursts of infrared activity. These bursts appeared in otherwise quiet galaxies, raising the possibility that dormant black holes had temporarily woken up to feed on stars. From this survey, scientists identified several candidates, and 4 of the strongest were chosen for follow-up with JWST. When Webb's mid-infrared instrument observed them, the results were decisive. The telescope detected spectral signatures that could only arise from black hole accretion. In particular, it revealed highly ionized neon, a hallmark of gas heated to extreme energies, along with strong silicate emission from dust grains glowing in the mid-infrared. These signals confirmed that the galaxies had indeed hosted tidal disruption events. Each case provided unique insights. One was the closest TTE confirmed so far, only about 130 million light-years away. Another coincided with a brief X-ray flare, offering a rare multi-wavelength view. A third showed evidence of gas moving at unusually high velocities, suggesting debris orbiting close to the black hole. These observations marked JWST's first detection of hidden tidal disruption events, offering astronomers a powerful new way to study normally invisible black holes. Scientific importance and theories. The ability to observe tidal disruption events in dusty galaxies matters because it finally gives scientists access to dormant black holes. Surrounded by clumpy, bright dust, structures are easy to find because their activity is continuous. Dormant. These, by contrast, stay quiet until a star happens to wander into range, making them far harder to detect. JWST has now shown that tidal disruption events can act as probes into this hidden population. The patterns observed in the 4 galaxies were different from the torus-shaped dust seen in active systems. This distinction provided a key confirmation that the black holes involved were not persistently active, but instead dormant, awakened only by the sudden arrival of stellar material. Beyond classification, these detections sharpen our understanding of how it interacts with its environment. By analyzing the energy and timing of the infrared signals, astronomers can infer black hole properties such as mass and spin. A star torn apart by a larger black hole, for example, may produce debris that falls in more slowly, while a rapidly spinning black hole might accelerate the process and emit stronger radiation. Each event therefore serves as a natural experiment that helps test astrophysical models. The findings also carry implications for galaxy evolution. Black holes influence their galaxies not only through steady feeding, but also through brief violent episodes like these. The energy release can heat gas, drive it outward, or alter conditions for future star formation. Because many of these events were previously hidden behind dust, astronomers may have underestimated how common they are and how much they contribute to galactic change. JWST sensitivity provides the first clear confirmation of dust-hidden TDEs, turning them from rare events into powerful tools to study dormant blacks in action. Implications and what's next. The confirmation of dust-obscured tidal disruption events is just the beginning. With JWST and future surveys, astronomers expect to identify many more. A larger sample will allow researchers to study patterns across different galaxies, revealing how often black holes feed and under what conditions. Timing will be a crucial part of this work. A tidal disruption event unfolds over months to years. By observing how the infrared signals evolve, scientists can track how long stellar debris lingers before being consumed. These timelines provide information about how efficiently black holes accrete material and whether they produce secondary effects such as particle outflows or jets. Upcoming facilities will make this effort even more powerful. The Vera Rubin Observatory, with its wide-field optical surveys, is expected to spot NUTDs soon after they occur. Those discoveries can then be followed up with JWST to probe the obscured environments in detail. Combined, these instruments will provide a multi-wavelength picture that connects optical flashes, X-ray bursts, and infrared echoes. Beyond black hole astrophysics, these also serve as natural laboratories for studying extreme physics. Close to the event horizon, gravity warps light and space in ways that push the limits of general relativity. Observing how debris behaves in these conditions offers rare data on the physics of strong gravity. The potential to measure black hole spin more systematically is another frontier. Spin shapes how a black hole pulls a material and launches energy into its surroundings, but it has been difficult to measure reliably. With enough of these studied in detail, patterns may emerge that help solve this problem. Extending our vision always reveals the unseen. Radio found pulsars microwaves the cosmic background, and now JWST's infrared is uncovering hidden it. These 4 TD are just the beginning. Outro JWST has uncovered hidden tidal disruption events inside dusty galaxies, proving that even when dormant, these can be revealed when they consume a star. This breakthrough opens a new path to study how black holes feed, grow, and shape their galaxies. Stay curious. The next revelation is just beyond the dust. Thanks for watching. Core.